Yo, what's going on YouTube? Welcome back to another hacking tutorial. My name's Chris, according to recent archaeological discoveries. And today we're going to be going over some server-side request forgery. Now, server-side request forgeries, also known as SSRFs, are a really cool way for an attacker to get a web server to basically make a request on their behalf. You're forging it as if you were coming from the web server. And this allows attackers to grab information from other parts of the web server, from other servers within the network, or get the web server to pull something from an external website, maybe a website where the attacker has some sort of payload, for example. So in this case, and it can get distracting by my artistic prowess, but in this case, we have an attacker right here. The name's probably Doug, and he wears a fedora, and he's a hacker. And he submits a request to the web server right here. Now, that web server is actually going to forward that request, and that request is either going to pull something from a database, something else within the local host, for example, maybe a password dump, or maybe even pulling something from an external website, as we mentioned earlier. And it may seem a little daunting and it may seem a little complex, but it's actually a lot easier and a lot simpler than you think. In order to demonstrate this, let's jump over to Portswigger Academy, where they have a really good lab that we can jump into and actually attempt to do a server-side request forgery to do some shenanigans we shouldn't be able to do. All right, here we are. So now what we're going to do in this lab is submit a server-side request forgery to another backend system, and we're actually going to try to delete another user without having admin privileges. In this case, to solve this lab, use the stock check functionality to scan the internal here 192.168.0x. So we're going to scan this range, this IP range, let's copy it really quick, for an admin interface on port 8080, and then use it to delete the user Carlos. So we know there's some sort of admin interface somewhere within this subnet, and we're going to then use it to delete somebody else. All right, so here we are within the lab. We can just go into any of these. We're going to scroll down, and then here's the check stock function. Now, before we start, all right, we got to make sure our Foxy proxy is on. Let's go to burp. Let's turn our intercept on. Check stock, intercept, and this is what we're attacking right here. So by default, the stock API feature is going to go to HTTP, the server here, 192.168.0.1, that localhost server, product, stock, check, all that stuff. So we're actually going to redirect this because we don't want it to actually go here. So we're going to actually send this over to the intruder because we don't know which IP within that subnet we're attacking. So for those that are new to burp, if you ever see this weird double S, whatever this symbol is up here, let me move my face. Yeah, if you see this weird double S little thing here, that's basically saying anything within that that's here in green is going to be a variable that's going to get fuzzed whenever we submit the payload. So we don't care about their cookie session. We're going to keep our cookies how they are. All right, we're actually going to change this right here. So this is what we don't. Okay, so we're actually going to have the request not send to. We're not going to send the request over to this to pick up to see how many items it has in the stock. We don't care about that. We're actually going to look for HTTP :// It was 192. Oh wait, right, we copied it. 192.168.0 and then X. So this X, right, we'll just put it at 1 for now. And we're going to go on port 8080/admin. All right, cool. So this one is what we're going to fuzz. So we highlight the last one. We add the little symbol thing. If anyone knows what that's called, please let me know in the comments. I've been just calling it the weird squiggly S thing forever. But that's going to be our fuzz parameter. Now we're going to go over to payloads. All right, payload type. We're going to look for numbers. Now we're going to go from 1 to 255. Although it shouldn't be 1 and it shouldn't be 255. Those are reserved. But we'll throw it in there anyway because who knows how this lab functions. We're going to go 1 through 255 and with a step of 1. I'm pretty sure default it'll go by 1, but just in case we'll put that in sequential. So now it's going to go here and it's going to start at 1 and it's going to input 2 and it's going to test it and it's going to say, what do we get? Then it's going to input 3. It's going to test it and see what we're going to get. Let's go back to payloads. Start attack. Yep. Basically telling us we're on Burp Suite Poor Man Edition, the Community Edition, so it's going to be super slow. But, I mean, fingers crossed it's going fast so far. You can do this on the Pro Edition, you can do it on the Community Edition. The only difference is the Community Edition is going to be slower. Okay, so I'm going to let this run for a while, and I will bring you back in a second because there's no point in both of us watching paint dry. So I'll bring you back when we get a hit. Before I bring you back, one quick thing to explain. Know your status codes, guys. It's very important. If you see a status code 400, that means that it was an error on our part. The website couldn't interpret what we sent. It was an error on our part. That's why you're getting it. It's like a 404 error, website not found or whatever. If you have a 500 status code, that's an internal server error. That means that there was an error on the web server side. That's good when you're looking for things such as SQL injections and stuff like that. In this case, we're just basically looking for anomalies. So 400 we don't care about. 500 we obviously don't care about. We're basically looking for any status codes. 200, which means it's successful. 300 redirects, stuff like that. So we're just going to filter by status, and we're going to let this run a little bit, and then now I will bring you back once we have something. All right, and it took us about maybe 3-4 minutes, but we did finally get a status 200 on payload 140. That's pretty cool. So let's go and send this over to repeater. Open this up, and let's see what it looks like. So we have here, 192.168.0.140. Let's send it. All right, awesome. So we did get the status that we want. Let's look up Carlos. Or delete, I guess. We're trying to delete a user. All right, and then here we can see there is a link here to delete username Carlos. Okay, so let's see what happens when we load this in and just try to do it ourselves. We go show response in browser. Let's just copy this really quick. Turn the intercept off. We don't need it right now. And as you can see here, using the link that we had forwarding it, we're able to get into here and we see an option to delete Carlos and delete. I think Wiener is us, if I'm not mistaken. I think that's how the nice folks over at Fort Sawyer Academy like to do it. Now, here's the issue, though. Remember, with server-side request forgery, the key here is that it's coming from the server. Right now, we're still logged in as ourselves. So even though we got to this page, which we shouldn't be able to, because you need admin access to get into this page, we're not able to delete Carlos. And you'll see here. We try to delete him, and it's just going to come back to not found. But if we go back, not to our intruder, if we go back to our repeater, and we submit the request from the local host or from the host, the local host that's running this, we do admin/delete query, and I'm just copying from here. Username equals Carlos. So if we do this and send it, we get a redirect, and the lab is solved. Now, why did that work versus the previous one? Now, the reason this works, once again, is because this is coming from the server itself. This request that we send to delete Carlos, when we send it through here, it's being sent through the 192.168.0.140 admin, right? That's what's being sending it. So it's not us, it's not Chris sending this request as we tried earlier when we clicked the delete button. This is coming from the server, and that's the important thing to note, is that the forgery is coming from the server side, and the server, in this case, has admin privileges to delete the user. So that's pretty much server-side request forgery in a nutshell. It was a very basic example, but I hope that's enough to actually get your feet wet. We can actually go later on into another video and do a more in-depth tutorial where we actually go and test against input validation, how to get around input validation. But that could be for a later video. Hopefully you got your feet a little wet. Hope you learned a little bit about server-side request forgery. It's something to look out for. If you're doing bug bounties, if you're doing capture the flags, this is something that is out there. Look for it. Especially dig into those APIs. Dig through them. See what you can get away with in those APIs. A a lot of different developers will not cover all their bases, and it's nothing against the developers. It's a lot of stuff to cover, and a lot of people that are doing software development don't come in with the cybersecurity mindset that us in this ethical hacking realm think of. We always think security first and then everything else. A lot of software developers are functionality, how nice does it look, how smooth does it run, and cybersecurity just isn't in their forefront. So that is something to look out for. I hope you enjoyed the video. If you did, consider dropping a like, subscribing. We're gonna have a lot more stuff coming out, and comment down below what you want to see next, what you thoughts on server-side request forgeries, and I will catch you guys in the next one. Later.